or good morning, depending on where you are. Thank you very much for joining this first TDL webinar of the autumn of 2025. Hard to believe the summer is over and autumn is about to begin. Very exciting discussion this afternoon on AI accuracy and the challenges associated with it. And we've got a great panel, and we've got a wonderful moderator in Claire Vishik, to whom I hand over now. As I mentioned in the recent email, any questions you wish to put to the panelists, do put them into the chat, and they will be picked up by Claire and discussed, providing they are obviously of appropriate nature. So over to you, Claire.
Thank you very much, David. I am really delighted to have this discussion today. This is something that everyone who worked with artificial intelligence in various areas, especially building LLM-based novel applications or systems, is familiar with. And as someone who had done a couple of decades of artificial intelligence, as well as a couple of decades of security and cryptography, it is especially interesting for me, having used artificial intelligence applications like GPT or Grok as a consumer, or for simple question answer mechanisms. I know that it frequently, most frequently perhaps, provides satisfactory answer, but also as someone who built novel systems, for instance, to define computer hardware combinations that are optimal, or semiconductor design, I know that this precision that is sufficient for consumers is not enough for technical applications. It's not sufficient without a lot of work in preparing data, in doing other post-processing activities involving humans to design the system that works relatively well, even when a lot of data is logs and metrics. So today we have 4 distinguished panelists who are going to provide their view on how can we deal with the issue of accuracy, how important it is, and how important it is specifically for security. A lot of security companies, such as CrowdStrike and many others, now use agents to speed up everyday activities for security professionals. How the sufficient or insufficient precision in this area can affect the way we view security, the way we understand what is happening better in a different way, the way we can be subjected to new, very sophisticated attacks. With that, I will briefly introduce our distinguished panelists. John Barras is a distinguished university professor and endowed Lockheed Martin Chair in Systems Engineering at the University of Maryland. Lorenzo Cavallaro is a professor of computer science at the University College London. Melvin Greer is SVP and Chief AI Officer at Tech Elevate Innovation Labs. And Corey Robinson is a consultant in data governance, privacy, and data ethics and AI ethics. He has spent a lot of time in academia also. You can read the bios of our distinguished panelists online. With that, I will ask the panelists to introduce their views on the topic briefly. Let's go in alphabetical order today. John, could you please start? What do you think about the issue of accuracy, specifically in conjunction with security?
Yeah, thank you, Claire, and thank you all for coming. And I'm very happy to be in this panel. It's a very good topic. Okay, so the problem is that especially in security, you can manipulate the AI results, or even if you don't manipulate, hallucinations can be disastrous. For instance, you can create panic by creating wrong attacks. You can orchestrate wrong defenses and many other things. We have standards for security, but we don't have standards for AI. And my view is that, especially with LLMs, LLMs cannot reason. So in security, if you cannot reason, you cannot do the job. So there has been many people that have noted that recently, and what is missing is actually linking LLMs to parts of AI that have to be there that they do reasoning, like knowledge graphs or semantic vector spaces and things like that. So the big topic that started being investigated, and believe it or not, actually started from a paper from the Harvard Medical School, because to some extent, I see a lot of similarity between medical diagnosis and security diagnosis. So what they did is they actually created domain-specific LLMs by being careful with the data that you feed. To make it clear for security, I would rather have LLMs that they are trained on specific data attacks, not all attacks, so I can actually understand some of the features of these attacks. And then I have many LLMs, which can be many domain-specific LLMs. The domain here is going to be different types of security. And then I go to the experts of security. I can create knowledge graphs for their knowledge. And what they did in medicine was, again, for each of the subcategories of a disease, they will go to an expert and get the knowledge. And then you have to link the two. If you do that, then you can control the output of an LLM and try to control hallucinations, so on and so forth. That has to be done in security, and it has not been done. The other thing that's extremely important, and people have talked about this a lot, is the integrity of the data. We have to have pre-filters on the data, whether it's security or social networks or whatever, to try to control what we're putting into these systems. Otherwise, you cannot, it's an amplification of the well-known thing in software, garbage in, garbage out. Here, you're going to get garbage into the 1,000 power in, and then garbage to the whatever out, okay? So data integrity is important. Both of these, the input and the output of these systems have to be standardized, in my opinion. We'll discuss this in the next question. And the other thing that I think is going to be important is you have to get industry and the users to accept the standardization. We have many examples in security that you give guidelines for security and people don't follow them. So human behavior and human understanding of these things and make them easy, it's going to be a very big challenge. That's my comments on this topic.
Thank you very much, John. You certainly gave me food for thought. I never thought about the ability, your opening statement, to create panic by providing information that mimics certain areas. Oh, that's very interesting. Thank you very much. Lorenzo, what are your thoughts? Or what are your thoughts on the matter?
Thanks, Claire, and thanks for the very exciting opening lines. So you touched on a few points I wanted to touch, so I'll just be a little bit orthogonal. I wanted to start off by mentioning Goodhart. So Goodhart stated that when a measure becomes a target, it ceases to be a good measure. So just to set the scene, we're obsessed by accuracy, right? Whatever definition of accuracy we have, but we also at the same time should try to see the problem in its entirety. So because if we overfit on the numbers, so we have 99 F1 score or 99 area under the curve of the ROC, what does that mean actually in practice? So I believe that in security, especially where you have a lot of imbalanced classes, not all the metrics are good for the problem that you're dealing with. So you need to first understand what is the metric that makes sense for your problem. Because if I have a very imbalanced data set, for instance, accuracy doesn't account for this. So I need to use other metrics like precision recall or precision recall curve and so forth and so on. I need to put into consideration the base rate fallacy, so that again exacerbate this differences between attacks and normality if we come from a security perspective. Just as to give a very quick example, in network traffic, you have the majority of network that is benign, and just a handful of things that are malicious in the greater sense of numbers. So having even a 1% false positive rate is a lot. So there's a lot of that you need to filter out from. And the other thing that I wanted to mention is what do we mean by accuracy? Accuracy with respect to what? What is the task we're measuring? Is it performance on clean data? Is it performance? Is it robustness against adversarial attacks? So attacks that undermine the security of the AI systems that we're using, or natural distribution shift that actually we observe because there's new knowledge that appears in the pipeline, or we're not precise to model the concept we care about, so we lose sight of what's working well or not, and this is manifested with different forms of distribution shift. So how can we measure accuracy in terms of explainability? But explainability of what? Explainability of the model, because that's one thing, or something that supports the decision-making processes. So explainability that is closer, tying up with LLMs, to human reasoning, which I agree with John. There's also some recent evidence that there's not much interesting reasoning happening there. There's a lot of interesting syntactic regurgitation, but a little bit less on reasoning. What are the costs to obtain all of this? Can we measure costs not just in terms of compute spent, but also time that we and challenges in obtaining some of the information we need to provide a specific metric? So I guess that's my view. My view is let's look at accuracy. Let's not try not to overfit on accuracy, because if we start to getting fixated about numbers, we lose sight of the meaning of specific metrics. But also we should try to identify what is it accuracy, because different tasks, different problems require different metrics. And when you get closer to human reasoning or natural language explanations, it's better for humans because we can interpret it, but actually measure whether the model is doing right or wrong, it becomes a bit more nuanced. It becomes a bit more than counting bins, right? Yeah, so I'm happy to hand it over.
Thank you very much. And you are making an outstanding point. What is accuracy? How this is a term that sometimes is precise, the proportion of correct predictions to all predictions, right? But it also is broad conventionally, meaning are we getting the right answers no matter what form the answers take? But are we talking about accuracy or precision, or maybe recall, or maybe we are trying to do something with something like F1 score? Really, the task that we have at hand defines what is important, if those metrics work, if we need new metrics. Very good points. Thank you very much. Melvin, what is your view on this?
I'm really excited that we're all here together talking about this term, accuracy. It is, as was mentioned, a bit of a misnomer, because when we think about accuracy in its raw sense, we're talking about something definitive, something that we can expect to be correct every time. But of course, AI systems are probabilistic risk models, and they typically act more like Monte Carlo capabilities than mathematical capabilities. And so I would posit that this discussion around accuracy is really how well an AI system's predictions or suggestions align with the correct outcome or the desired outcome based on the data that it was trained on. Not anything to do with reality, nothing to do with exactly what it is that it's measuring. More specifically, a focus on how well its predictions or suggestions are related to the desired outcome based on the data. And so this is a ratio. This accuracy thing is a ratio of the correct predictions to the total number of predictions made. But it's not the only thing that measures whether or not an AI system's performance is doing exactly what it's supposed to do. And so one thing we don't want to do is conflate performance and accuracy, because this idea of accuracy can be very misleading based on the use of imbalanced data sets to either manipulate or, as was discussed, change the output of the suggestions or predictions. And so, yes, accuracy is a major concern, not only in cyber and security, but across the board in any domain space that you want to think about, fintech, education, defense, uh, because without demonstrable accuracy evaluation, what we're seeing is, in spite of the fact that it has not had a material impact on the investment in AI, it is having a material impact on the AI adoption. And so while the general public may be satisfied with this lack of an ability to get to a real understanding of the both accuracy and performance of AI systems, professionals would expect that AI systems are held to a higher standard. We would expect that we would not um, use their output without significant human review if that accuracy was significantly less than just a human doing it in the first place. And so the idea of understanding the rational need to measure how well an AI system does with relationship to the data that it's being fed is really a material activity that will have a material impact on AI adoption across the board.
Thank you very much. This is fascinating, and I hope we'll be able to probe on it later in connection with the nature of human expertise, the potential erosion of human expertise in this context, and so on. Thank you very much. Corey, what do you think?
Thanks for having me, Claire. I think AI accuracy is a serious issue, especially where security, privacy, and trust are on the line. But accuracy isn't just a model score, it's social and ethical property. In these contexts, errors cut both ways. Low accuracy misses threats and misleads decisions, while high accuracy can become over-intrusive, enabling deeper inference and surveillance if governance is weak. We also have to consider perceived accuracy. Polished outputs and confident tone can create misplaced trust and automation bias. That's where human expertise matters. So professionals need collaborated signals, provenance, and the authority to question or override the system. Today's checks, whether that's reference matching or answer relevant, they're useful, but they're insufficient. They rarely tell us whether output is reliable for this task in this setting at that risk level. My lens is governance. Treat accuracy as context-bound reliability tied to rights, impact, and accountability. So if we link measurement to purpose, uncertainty, and consequences, not just benchmarks, we're going to make AI safer and more trustworthy.
Yeah, thank you. Thank you very much, Corey. It's there is always a human and therefore an ethical element, even when the systems are not human-facing, when we are measuring logs from a production line or weather metrics that were collected by various weather stations in order to attempt to formulate predictions. Several interesting things, well, a lot of interesting things were mentioned here. Let me probe on a few of them. I have heard, and I actually have noticed that there is a connection between the easy access to LLMs and their ability to produce some superficial answers and the way human expertise is used. A lot of consummate professionals use artificial intelligence for speed, for tasks that may not be considered very important, but also for tasks that are important. Well, for instance, recently there was a mention of a brief submitted to the US Supreme Court that had 2 of 17 references as hallucinations. So clearly, whoever produced this very important document did not check the accuracy and correctness of what was there. I would like to hear your comments, especially in technical fields and especially in security, where not recognizing a risk or a threat could lead to very serious consequences. How the trust in at least the superficial abilities of AI systems can affect the human expertise and how it is used day to day. Who would like to start? Well, John, would you like to say something on this subject?
Yeah, I can become a little more technical. So what I think is missing is what in engineering we're calling testing, validation, and verification. Okay, so if I had, let's stick with networks. Okay, in networks I have operation models. I have protocols at all layers, which can be formalized. So I can use very heavy-duty formal systems to try to analyze them, going all the way from model checking to even now we're using automatic theory proving. One of the issues with these techniques, which have nothing to do with AI, is that they are heavy computational, and sometimes in security, you have to decide quickly, because if you're slow, you're not going to catch the spreading of the attack. So an important issue here, there are two computational or quantitative issues here. Trust, and for me, trust means not just words, but you have to have a way to compute task, and you have to prove to me that you have the data to compute whatever you mean by trust. So you can have a source of data, and you can assign it a scalar or multi-dimensional trust, okay? And this has happened, and then you can use this to analyze information and decide, whether you can decide correctly or you have a problem and so on and so forth. And trust in our analytics and mathematics is connected to risk, which is another very important topic, all right? Actually, the two are related. To give you an idea, if you have high trust and you take one over trust, the risk becomes, low. If you have little trust and you take 1 over the trust, then the risk becomes very high. So this has been mathematized, starting from finance and so on and so forth. I would like to see more of these things to security along the lines of, I want to have systems that they monitor what the network does at different layers, and then be able to adjust or detect abnormalities, and then be able to adjust. Not all the time automatically. I mean, my belief is that in security, these AI and machine learning systems will become assistants, not the final decision makers. Okay, you're always going to have some supervision from humans to allow for things that you were not able to model or the data that you haven't seen. And let's emphasize something else. Security is important to understand component-wise. Nobody attacks a system. You cannot attack a system everywhere. You attack it to components. So if you try to explain, you have to be able very quickly to identify the source of the attack and the cause of the attack, whether it is an opening you see in a software system or in a hardware and so on and so forth. And that localization of the cause of the attack is extremely important, of course, for networks, because you have billions of users and devices. So it's important to be able to do that in multiple scales, meaning to understand both in time and geography. And we have run into this problem again and again in networks. I have a problem. The quicker you localize it, you can then constrain it, meaning one of the things we try to do with controlling accuracy and develop standards is stop it spreading, okay? Whether that's in communication networks or in systems or social networks, if you can localize and constrain it, then you are ahead of the game. So I am in favor of developing more analytics, scalable analytics, and monitoring things which use not just data, but logic and models that we know we have in the operation of the network. As a matter of fact, there's been work that you can even give a bunch of models, and then the systems, both in terms of analytics and now careful mathematics from AI, like knowledge graphs and others, you can see what vulnerabilities the system has. You can find vulnerabilities that the human will not find. And I mean find means know that something may happen and be exploited before you see it, because you cannot see it just from the data. So this ability to use these models and try to do a little bit of predictive work and be aware of what might happen is important, and it will help in terms of accuracy, because it will tell you where to look and what accuracy means. I mean, it's not just the detection metrics, but it's also time and so on and so forth. And the last thing I'm going to say is I am in favor of collaborative security, meaning several people, several systems collaborate for security. And that's very important, but it's not well understood. Okay, because if I see something wrong, I should be able to alarm you and vice versa and so on and so forth. I don't know if this is helpful, but that's where I'm going with these problems. Thank you.
Yeah, it's impossible to disagree with the view that the multiple systems that are necessarily engaged in one process today always need to work together, as well as that there is a limit to what the analytics could do in terms of decision making, but they could be improved to do somewhat more. So another question based on what was said.
Hey Claire, I do have a point to talk about this first question that you raised, if you don't mind.
Yeah.
Yeah, so I
Yes,
think
please.
the semantics that we are using in the question that you ask are really important because we've fused three very different things. This idea of security, which is a technical measure. We have lots of standards around security, and we have a way of confidently measuring whether something is secure or not. Then we've put privacy, which I consider to be a very legal thing and not very much of a technical thing, right? Privacy is what the law defines as private, and it brings in a whole series of things that Corey talked about in terms of ethical behavior and the ability to judge whether or not something's right for a right at this time. And then we've added trust, which is a measure of confidence and almost an emotional thing. So these things are very different, but I will say that the lack of accuracy in AI systems is having a profound effect in terms of creating false positives for legitimate activities. And this could be whether it's in security, we're using SIM and audit data to try and evaluate a vulnerability or a threat. It's the same thing that could be done in law enforcement, where we're trying to identify someone who's a potential threat or someone who's actually broken the law or not. In finance and healthcare and in every domain space, this idea of a lack of accuracy is dangerous and it erodes trust and can have a material impact on privacy as a function of its ability to be deployed properly. And so the second part of your question, which I thought was really interesting as well, is this impact on human expertise simply means that as a result of the inability of AI systems to meet the necessary bar, not just in security, but in privacy and trust, it will require that humans continue to take responsibility for the critical thinking, the nuance, the common sense portions of a decision in a greater and greater way. And so it means that while some human skills are going to be easily to replicate in terms of automation, this idea that AI's confidently incorrect answers are not serious is, of course, incorrect. And so we will continually need to have those decisions, those suggestions reviewed and validated by human experts.
Thank you very much, Melvin. That is a very deep, nuanced answer that got me thinking about a lot of areas that what you said could potentially affect. Lorenzo, there are a lot of things that are standard in thinking about security. For instance, threats are evaluated based on their probability and their impact. But usually there is a human element that sort of provides calibration rather than simple metrics with regard to very impactful but very rare security attacks. How do you think this metric plays out with regard to using AI agents instead for areas that need quick decision making? Is it possible, or is it impossible to substitute humans in situations like that?
I love the question. It's very tough. Very thought-provoking. And I guess, I wanted to I guess, connect a little bit with Melvin and what they mentioned. And maybe I have a very short prelude to before answering your question. So I believe that one thing that is important, we've always known in security, it's been important both in academia work and in industry, is about the threat model. So you can't secure a system 100%. We all know that, right? So it's about defining threat model. It connects with what John mentioned about risk, right? So you have to define your threat model. But in AI security, this is even more fundamental, I believe, because there has been a surge since 2013 or about um, um, around adversarial attacks. So attacks specifically crafted against AI systems. And I'm quite broad in terms of AI systems. It could be traditional non-LLM systems, that are, prone to adversarial misclassifications. We can call it hallucinations in the terminology of LLMs, but also you have the same type of attacks that now take the form and terminology of Fencer, like, adversarial prompt, jailbreaking. They all, there are all instances of old stuff that we've seen in other systems, right? So I believe that, one thing that we need to consider is making sure that our threat model is realistic. And it might seem obvious, but not necessarily sometimes, because when you go down the rabbit hole to understand whether a model is vulnerable to an adversarial attack, well, most of the time it is, like in the proper adversarial AI perspective, because the way that we craft these attacks stems from the same way that we train the model. So it's about from a technical perspective, you want to minimize the loss function and you differentiate the loss with respect to some weights when you want to train. But in this case, you differentiate with respect to the input. So you want to find the adversarial perturbation actually causes misclassification. It's a bit of a technicality here, but if you scrape out all the maths, it means that you can break a model with enough budget. The question is the adversarial example you're creating realistic? So does it correspond to a malicious network flow? Does it correspond to a malicious application? Does it correspond to to an application that has a vulnerability? If so, that's a real threat you need to deal with. If not, you're just showing that the model is vulnerable, which is good. You need to know that. You need to know what you're dealing with. But at the same time, you need to consider this, as John mentioned, as components in a bigger ecosystem, right? You want to know the limits of each and every one of them, but also you want to know the realism that you have around that. So I feel this is very important. Now, to get to your question, Claire, I know I promised to stay quick within 2 minutes. I guess you already overflown that. But it's very hard because it depends on the task, right? So LLMs are very helpful, like especially agents. But we know that we need to now the fancy word now is grounding. We need to ground the agent into something. We need to ground the agent into tools. We need to ground agents into semantics. And I've been very fuzzy when I use the term semantics. What does it mean? It depends on the task. It depends on the domain. It could be what programs are meant to do, and also how do you define that, where we have all the different formalism that we can define this, but in other domains it's a little bit fuzzier, like you can't really do that. So you need to make sure that these models are grounded. Yoshua Benjo, not long ago, he founded, like a few months ago, a non-for-profit organization called Low Zero, where they argue that you need secure AI scientists, which is a non-agentic LLM model to guardrail and check that these agents are grounded, like, and don't go around. And this connects to, to your point. How do we know whether they're doing right or wrong? It's very tricky. It depends on the task, especially on what sort of output you have.
Thank you. It's fascinating. I agree. It's probably not a very scientific term, tricky, but it's probably the best word I can find. It's very difficult to form a determination in something that has more data calibration than predictive capability. When all is told, it's very difficult to look at it and be certain that the answer we are going to receive on an unknown, undefined object is going to be correct. Excellent responses. Let us move towards the issue of standards. It's, as we all agreed, very difficult to define a standard set of metrics that apply to everything, even in a domain such as security. It's well-defined, although a broad domain. Is a framework that we already could use to define some level of accuracy that applies to security, or maybe several standards? Corey, this is your area. What do you think? You are on mute.
Sorry, my internet cut out. Do you mind to say the question one more time, Claire? So sorry.
Yes. Do you what do you think the standards framework for this set of questions could be? Is it possible to define metrics for a domain such as security that deal with AI accuracy adequately, or do you think it's not possible?
Thank you, Claire. I would say that emerging standards already exist. If we look at the EU AI Act, ALTI, etc., they're principle heavy and they miss sector specific harms. But as an example, in media, accuracy connects directly to pluralism and misinformation. In healthcare, to patient dignity. So yes, accuracy is connected to governance, but we need binding standards that tie that accuracy metric to rights-based obligations, not just these technical benchmarks.
Thank you. There is a good general, perhaps legally oriented framework that is helpful. Now, John, do you think there is a mathematical view of accuracy in security systems that can help us? Do you think it could be defined as a standard?
If we stick with the engineering side of the problem, the answer is yes. If we endeavor to go to human behavior and all that stuff, the answer is no. For the simple reason that we actually don't understand humans. I can give you stories about decision making and so on and so forth. It's a very active area of research and so on and so forth. If I'm going to stick with a technical aspect, like I have a network, I have to manage it. There will be a manager looking at a control station and so on and so forth. The problem I see is decomposability. In other words, you're not going to be able to understand security attacks by looking at the global data. You have to very quickly zero into the relevant data and the relevant source of data. And as we know from the history of security, we have had systems that you're very well aware, Claire, in NIST and other places where they will give you secure components, software and hardware. You put them together, and there are theorems telling you that what you end up with is an insecure system. So the area of composable security is still open. There have been some advances. And this affects now AI, because you are adding now an additional component to whatever you have from engineering that is highly non-measurable, and you still want to have composability, okay? So this has to be addressed. So if there's going to be any standard, you're going to have to tell me how am I allowed to put what I have already classified as secure together, and then have some guarantee that what I get is reasonably secure, okay? And typically the theorems say that I have to have other parties giving me certificates and other things that they guarantee this composability, okay? If you go to humans now, okay, what we know, for instance, we have studied Sweden, where I also work in Germany, that the degree by which humans obey the guidelines you give them depends on what job you are, what sex you have, what city you live in, and so on and so forth. I don't have any idea how we can control that. I mean, I'm sorry. The technical side, I can see evolution that in 1 or 2 years we're going to have standards for AI that are additional components and machine learning components to the current systems. And with collaboration with humans, you're going to be able to get reasonably good standards for security. When we go into things like, social networks, human behavior, and so on and so forth, I don't know. And the other thing I want to emphasize is what Melvin mentioned, is you have to be careful, because you cannot make the security system so strong that that the human is prevented from using it.
Yeah,
So
Claire, I would
that's
also,
yeah.
I would add to that as well. I mean, I think this idea of security is really great. You know, we've had some precedent when we talk about extending enterprise class security to the cloud and using some measure of cloud additions to ensure that we can extend the enterprise class security to cloud for things like FedRAMP and high authorization and third-party authentication and these mechanisms. I would argue that we have not done a very good job of extending that to AI systems. And the reason I say that is because they tend to be more robust, highly dependent on the data, and the threat landscape for AI systems is so much different than the threat landscape for enterprise or even cloud hybrid systems. The sophistication level required to create real threats to AI systems is very, very low. I mean, something as minimal as data starving or data poisoning can have a material impact on the ability of these AI systems to operate well. And so what I would say is that while we have things like ISO and NIST and other places that try and describe security in its most technical frame, the ability to extend that to create AI systems that are trustworthy, fair, accountable, or accurate, as we want to say, I think we have a long way to go before we get there.
Absolutely. It's impossible to disagree with it, but I am heartened to hear John and to some extent you saying that we can standardize and maybe address the issues in systems, if not in humans. I think the composability, the framework where there are multiple systems, but you need to adjust and coordinate their security models. The feasibility of this was viewed much more skeptically even 15 years ago. So that means that we made some progress. There were a lot of comments before with regard to data, that it's the context, the task, and the data that define how we approach accuracy. What do you think needs to be done with regard to data in order to improve accuracy, at least at the system level? Corey, what do you think about that?
Yeah, it's a great question. So I would say that accuracy depends on reliable data first, but governance has to come first. Minimization, provenance, and purpose limitation. Even when we're talking about logs or network data, not human-centric data, the same principles apply. My work on data marketplaces show that people trust systems when they know where the data comes from and why it's collected. So the requirement is not collect more, it's collect with purpose and transparency.
Thank you. That is something that is impossible to argue with. One area of data that I have encountered in building systems such as self-driving cars, for instance, is data completeness. The fact that the data embraces as many aspects that are needed to operate a system as possible. Lorenzo, what do you think about the issue of data quality and data completeness? How can it be dealt with?
Oh, sorry. I thought that the question was, what do you think? It's very important, and I thought the job was done. So, how can we solve it? Asking the wrong person. I have no idea. So, but I have a couple of insights here as well. So, I agree with what Corey just mentioned. Purpose and transparency. That is amazing, and I guess this will be the platonic ideal. So the problem is that I believe that what do we do? So I guess this is what we should be aiming for, but what do we do meanwhile, as we reach that point? Because also not all the data is equal, meaning not of equal importance, but also not all the data is genuinely trusted to start with. Think about attacks instances when there's no way that you will be able to collect them transparently to some extent. And purpose, yes. The problem with all of this is that a lot of this data also is proprietary, so it's considered to be IP by players. There is sharing, of course, but it's sharing within a vetted community, which is fine, but it means that only a few can still get access to high quality data, and for obvious reasons, like it shouldn't be open to the world in general. But this is, of course, creates a little bit of tension between transparency, open source in a sense, and what is considered to be potentially dangerous that you want to sort of vet and protect. There is a recent work now. If you now consider, okay, what about data quality? What about data that it is out there? So there is a recent work that was published in Nature by I guess Nicholas Papenot at University of Toronto and a few others. Actually, try to understand what happens as the model will get access and it will ingest more of data data that is being generated by the model. So we're going to have better answers or worse answers. So it seems that there's a tendency of getting much worse result, like getting worse accuracy. I want to come back to the original theme, which is very daunting, because we have abundance of data. There's a lot of data, but it seems that we are constantly data hungry, more and more. But more sometimes is less. So sometimes we should be focusing on quality. So of course, if you think about foundation models, they try to build out their relationship and have a large quantity of data, like data-driven. And this connects with what John mentioned. Maybe we should also embrace more neurosymbolic reasoning, knowledge graphs, like root and ground our data-driven approaches in knowledge, like in logic as well. At the same time, not all the data is created equal. Not all the data is good. Not all the data gives you access to a certain region in the manifold, like that you care about, that will be useful for continual adaptation. So I just realized that probably I haven't fully answered the question, but the point is that data is very important. I agree with Corey, but it's very tricky to do it in general. Even if we could implement something a greater scale, there's always be something that will be missing because of IPR, because of regulations, because of certain things as just attack patterns. So they're not going to have attackers if yeah, sure, there's my malware and stuff. So you need to wait until this surface.
Yeah, I think tricky is probably the understatement, Lorenzo, because I was struck listening to Corey, and I really appreciated what he had to say, but it is almost adversarial to the way professionals in our field treat data. We treat it like it's free, like it's available anytime we want to, like we have actual rights to it, when the lack of data sovereignty as it relates to the way we treat data complicates not only the ability to use it well, but to inspire trust in the output of the analysis. And so because of that, while we talk about this idea of, yes, we should have more transparency, researchers, AI professionals, practitioners, data engineers, these are the people who are constantly saying, oh, but that's free and that's public domain data. And in fact, somebody actually owns that data. There is actually a sovereign owner who may, feel very, very dispossessed, not only because they haven't given express consent to it, but they don't actually benefit from any of the economic results that the analysis of that data is driving. And so what I'm finding is that our ability to actually improve accuracy when it comes to data governance is directly related to our inability to drive data sovereignty and transparency into the system.
Excellent points were made here. It's impossible to disagree with them. It also confirms my own observations. Having more data, sometimes high quality data, does not always lead to better accuracy. There are additional data manipulations, symbolic manipulations, algorithmic decisions that are needed to connect better data to better answers. Obviously, better data is necessary, but other things are necessary to lead to increase in accuracy. maybe there will be better access to data eventually in a few years. I think all of us have heard that now in data intensive areas like experimental physics or medicine, many journals require data to be provided with the paper to consider. I think that is a very important step for a variety of reasons. But also, my hope is that it will make more high quality data available and lead to more scientific techniques to process this data so that the accuracy can be improved. On this note, let's go to the last question. What do you think are the most promising technical areas, methodologies, scientific approaches that could lead to the improvement in broadly understood accuracy? John, what are your thoughts of it? What is promising?
So I'm very confident that in about 1 or 2 years for engineering systems, right, networks, autonomous cars and all these things, we will have standards that can be measured and applied to give a metric of accuracy and its consequences to the autonomy and control of the systems, okay? I have no confidence that we will do that even in 5 years for human data. Data is a tricky question because, as several of you mentioned, more data, and now this has been proven, doesn't mean better. The key question in my mind to be addressed is how do I efficiently integrate model knowledge or domain knowledge with selective data to try to make sure that the combination of the two, if it's done properly, it gives me better understanding what I mean by accuracy, what it means threats and all that stuff. And the last comment I want to make, in security and in many other dynamical systems, you will never have the gazillions of data you have, for instance, for applying machine learning to face recognition or adversarial attacks. You will have a smart attacker will not do the same attack again and again and again because she or he will know it will be caught, okay? So being able to deal with this problem requires exactly what I'm saying. You have to integrate your model and the knowledge to something that's quantifiable and usable together with selective data. And in that extent, test beds and be able to find what exactly experimental data you do, which cannot publicize because you don't want to have repeats of the 0-day attacks, okay, where I publicize the attack and I don't correct it and people come in and throw, all kinds of problems in my network. This is what we're working on. We're working on heterogeneous networks with SDN, NFV, all that stuff. These are humongous software systems. You have to decompose them and understand the security from components up and understand what role data play here and what your knowledge plays here, and then try to put them together. So again, last sentence. Engineering and networks, I'm confident that we will develop these systems. When you start putting human data from social networks and so on and so forth, I'm not very confident.
Yeah, I agree with you. But even on the system side, having greater access to understanding and accuracy, speaking at a very high level, is very important. Thank you very much. Corey, what do you think? What are the promising directions that can increase accuracy?
Yeah, I'd like to highlight 3. So first, privacy preserving ML methods like federated learning, those balance accuracy with minimization. Second, calibration and explainability tools so that users can judge when the outputs are trustworthy. And lastly, for me, the most important is ethical benchmarks. In ed tech and healthcare, we've shown aspirational standards can guide responsible design. As for timelines, accuracy will improve incrementally in around the next 1 or 2 years, but the real gains depend on the process and governance innovations, not just the technical fixes here.
Yeah, there are no technical fixes for everything. Is all of us with decades of research behind us know. Thank you very much. Excellent point. Melvin, what do you think?
Yeah, I'm really going to focus on the non-technical ones as well, because I agree that on the engineering side, we likely will move forward. I think 2 things. One, the fact that AI professionals are even starting to ask these kinds of questions of the systems that they're developing is a very positive thing going forward. This is a good thing. And the more forums we as AI professionals start asking these hard questions of each other as developers is really important. I think the second thing, which is non-technical, is that we're inviting people who do not have AI backgrounds into the conversation. Ethicists, sociologists, anthropologists, people who do not have a technical bent. We're inviting them to have this conversation so that we can stop this maddening pouring of resources and investments into something that's generating very, very little ROI on the back end when it comes to being adopted by the vast majority of people. I mean, every month or so we get a new term that has another great set of promise, but we don't have a roadmap for adoption that people can actually get behind. So I think the non-technical things are really the things that we really kind of need to continue to focus in on. And again, I can't emphasize enough that we should do this on a global scale. I don't think it's reasonable for one country or even one set of economically aligned countries to try and drive the kind of accuracy, adoption, and trust in security that we're talking about. Because the very nature of the fact is that the systems that we build for AI, there's a whole another set of people who are using AI just like us to break those systems. And so uh, AI is not only the enabler, but it's the adversary. And so there's a need for us as a civilization to start thinking more about uh, how we're going to collaborate and less how we're going to be continually adversarial.
Thank you very much, Melvin. And indeed, even for very technical problems in security, the non-technical aspects continue to be important. As was pointed out, they are less tractable, but they are there, and we need to learn to look at them in a certain formalized way. Lorenzo, what are your remarks about the promising directions? What are they?
So let me just start off by saying that I agree with John, Melvin, and Corey, and this is not me being politically correct, or academically correct. Then I guess everyone is coming from their own expertise, from their own angle, and I agree with that. I guess Corey mentioned something I'll be back to in a second. The one I want to mention here, I'll be very abstract, is that I believe we need to start reasoning about semantics. So and how we achieve this, it's irrelevant. Either you ground the reasoning of the model in, knowledge base, in logic reasoning, neurosymbolic AI, whether you provide data that represent things that you care about. You're sure that this is very useful. And then it's a way to ground the model in meaning, right? So to help the model to get to a good answer. This is something that reason with LLMs, but also with non-LLMs. So you can learn proper semantics. So instead of saying, oh, I use this convolutional network on network traffic. What does it mean? Convolutional network is being designed to deal with image properties. Whether it does a good job or not is a separate story, but it's been designed to cater for specific data properties. So we should start designing models that cater for our own data properties more thoroughly. And the second point, I guess, and this already will give you, the ability to reason about, to obtain robust reasoning. Let me just pass the term reasoning, let me double quote reasoning a little bit. And the other point, I guess, that Corey mentions about calibration, this is so dear to me. So again, in the system security research lab at UCL that I lead, we've been doing a bunch of stuff in what I just mentioned. So it's not just my perspective. So we've been working a lot on uncertainty quantification and abstention, which basically are all machine learning techniques we applied on code. And it doesn't matter where you apply this to, but basically models can be wrong. And we just need to equip the model to say, I'm wrong. That's it. So you need to trust the model. You need to know when the model says I'm wrong is because, I don't know the actual answer instead of telling you, yeah, this is the answer, right? And there's a recent paper by OpenAI actually that tries to give a little bit of, in the LLM era, tries to give a little bit of insight of why model hallucinates. So one is about, because the model is stochastic, stochastic machine, but also because we reward the models to not make mistakes. So to tell us, the right answer. So they kind of pushed and reward to do that. And actually that's what they regurgitate. Maybe we should try to change this and disconnect with calibration. So from a probability perspective, you have calibrated output. You are more confident on the trustworthiness of the answer. So and then you can build rejection approaches, abstentions to say, okay, I don't know the answer, so help me. And then you can have a human in the loop that is integrated properly into the conversation instead of something that is being thought of as a component, post hoc component.
Thank you very much. That could serve as our concluding remarks. We are at the end of our hour. That was a fascinating discussion. We came to some conclusions that we can deal with the technical aspects better than with the human aspects. We need to focus more on the human aspects. We need not to forget about the ethics. We need to take care that the data is representative, but having more data is not always the answer. We need to improve the models and teach them to reason in a way that is constructive for situations when there are no answers. We need to treat AI as both a helper and an adversary, and treat AI agents, especially in security, in this way. And many other very useful points were made. I hope we will be able to meet again in a few months to discuss specific metrics and how they could be applied to security situations. I am really looking forward to it. For now, thank you very much for taking part of the panel and for the fascinating discussions we had today. With that, I pass to our host, David Goodman, to conclude this discussion.
Thank you, Claire. And it just leaves me to say thank you to all the panelists and to Claire for a really fascinating discussion on a subject which will, the conversation will not end today, as Claire just indicated, and it would be great to come back and review where we are in a few months' time. So thank you all. As I mentioned earlier on, the recording of this will be available in the next few days, as will a summary report. And thank you for our participants, for people listening, and for people staying to the end. And I wish you all a very good